We've talked about overfitting and testing a bit. Overfitting occurs when the model learns to predict the data we've given it so well that when applied in a real-life situation with new data, it fails miserably. One way to deal with overfitting is to hide a small part of the dataset from the algorithm. So, we train the model based on most of the data, but not all of it. After that, we use the small piece of data we left aside to test if the model will do well in real life. And that's basically the topic of this lesson. We will split the dataset into train and test so we can assess the model's accuracy on data it has never seen before. Okay, we've also talked about shuffling. We want to shuffle the data so that we remove all types of dependencies that come from the order of the dataset, like day of the week. Time to put that good knowledge to use. As usual, sklearn has a pretty neat method of splitting the data into train and test. In order to use it, we must import it though. So, from sklearn, model selection, import, train, test, split. The train test split method is very powerful and has many arguments. The two most important ones, however, are the inputs and the targets. Let's indicate them here. Train, test, split, parentheses. Our inputs are contained in the variable scaled inputs, so I'll put that there. Our targets are contained in the variable targets. That's clear too. That itself is enough for the method to split the data. The output we obtain consists of 4 arrays: a training dataset with inputs, then a test dataset with inputs, a trained dataset with targets, and a test dataset with targets. Obviously, this output is of no use per se, so let's declare 4 variables that will contain the 4 outputs. Conventionally, we will call them xtrain, xtest, ytrain, and ytest. So, let xtrain, xtest, ytrain, ytest be equal to the train test split method with arguments, the inputs, and the targets. Okay, great! Now, I suggest that we see the shapes of these variables. This will be very indicative of what the train test split has actually achieved. As you can see, the training inputs are 525 by 14, while the training targets 525, comma. This tells us that the inputs contain 525 observations along 14 variables, while the targets are a vector of length 525, the latter corresponding to the excessive absenteeism column. Exactly what we expected. 525 observations, 14 inputs, and 1 target value per observation. What about the test? It includes 175 observations, 14 input variables, and 1 target variable. So, this method has basically split the scaled inputs and targets into matching forms that we can now use in the machine learning part. While this code would do, we can also take advantage of the rest of the arguments that can be specified in the train test split method. The split we just got, 525 training and 175, is 3-to-1. In other words, 75% of the observations will help us with training and 25% will serve for testing. That's obviously the default split. Usually, though, we opt for splits like 90-10 or 80-20. We don't like setting aside too much data for testing because this means we are going to train the model on less data. How can we specify that? We can go back to the function and set the parameter train size equal to a certain value. Train size can take values between 0 and 1. If we write 0.9, this would mean that 90% of the data will be used for training and 10% for testing. If we write 0.8, this would mean that 80% of the data will be used for training and 20% for testing. Usually, I go for the 80-20 split. So, the train size argument becomes 0.8. Okay, is there anything else I'd like to tweak in this code? Sure. We spoke about shuffling on several occasions. The train test split method has a shuffle parameter. Shuffle is a Boolean, so it can be either true or false. By default, shuffling is set to true. Let's check this. If I go back to this cell, here, and rerun it, we would get a different split. Do you see the change? So, sklearn is quite smart. It is not only taking care of the split, but the shuffling too. This, however, may be a small issue for us. When we rerun our code, we get a different shuffle, and this means a different split. This causes the final model to differ every time due to the shuffling. Now that's unfortunate, because we may either get lucky and achieve a higher accuracy than it should be, or we can get unlucky and achieve a lower accuracy. So, the shuffle can make things difficult for us. There is a simple solution though. All sklearn functions that include some randomness, like the random shuffle here, contain a random state parameter. Random state takes integer values. What we can do is set the random state to a number, say 20. This will make the shuffle pseudo-random. It will always shuffle observations in the same random way. Alright. Finally, let's check the shapes once again. We've got 560 observations for training and 140 for testing. So our 80-20 split worked as it should. In the next lecture, we can get to the heart of the algorithm. Thanks for watching.